Hey there guys, this is AdamantLife. Welcome to episode 7 of Big Pycture Python, the Python tutorial series where we start out with the big picture and then fill in the details as we need them. So since we've gotten into the habit of making adjustments to our code at the beginning of each episode, I decided to make one minor adjustment, and that is we'll be changing sword to weapon to give us a little more flexibility. Technically changing the item name or the attribute name doesn't actually do much at all, but it does set us in the mindset that this could be anything from a sword to a spear to a bow or maybe even claws or something like that. So we're going to go ahead and just change sword to weapon, and we'll rename the sword class to weapon class. In that class, I'm going to go ahead and leave the default item name as sword, so if we just randomly create a weapon, it will continue to be a sword. And down here with Jimmy, I'm just going to explicitly state that the Worm Slayer is a sword for the heck of it. Because Worm Slayer could be a lance or something. So, very minor update to the code, just something going forward that will help us, rationalize the things we do in the coming episodes a little bit better. As for this episode, I promised you to go over XML, so we will hop into that. And to help us, I pulled up an XML file that I use. This is part of my anime library database. I will say at the outset here that there is an argument to be made for databases to use actual database languages, such as a relational database such as SQL or something like that, SQLite. But for the time being, it's one of those things when you're programming the right tool for the job at the time, and currently this is working just fine, this XML as a database. So what do we have here to break down what an XML file is, in case you don't already know? We have elements. Those are the things in these brackets. Each of these brackets, so library here, and then if I scroll all the way down to the very bottom, we'll see that it closes with \library as well. So elements open and close if they don't have any text in between them. So text or elements, I should say, because this library has elements within itself, and these tags here have elements have text in between them. But if they don't, for example, in the related tag right here, the related element, you'll see that you can just end it with a \, at the end of the opening element. So if it doesn't have text or other elements inside of it, you can still keep it inside of the element that's the parent element. And that's good for, if you're going to be iterating over this element looking for specific things. That way you don't end up not finding it. Otherwise, we can put text in here. This is all going to end up being text, so we're going to have to convert it if the number back out to a number when we pull it back out, or a boolean when we pull it back out, alternatively. Inside the tag itself, we have attributes. So here we can see that my library has an attribute called type, which is anime, and a name, which is anime library. And those are the major things. There's a couple other things that end up in XML files, but we're not going to end up talking about those right now. So we will go ahead and move on to actual code. So if we scroll down bottom here, we'll go ahead and just set these up. So we need a load and save for XML. Define save XML character. And it takes a character and a file name. And then what we're going to do is basically if we hop back over to that, this very first element here that everything else is inside of is referred to as the root element. So library is my root element for this thing, for this XML file. But in Python, we actually have element tree as the actual class object, and then the root element separately. So we're going to go ahead and create the root element first. So element character, and that's how we do it. If we pass this character, the first argument in an element is going to be the tag name, and then we can pass it stuff like attribute equals, and then it ends up being a dictionary for attribute. Right now, I can't think of anything that we could have the character's name as the attribute. Actually, let's go ahead and do that. That way we can use this attribute. Otherwise, I don't see us using the attribute argument for anything else. So, name equals character.name. So, the major difference, I'm going to say really quick, between XML and JSON is that XML is not a dictionary and therefore can have multiple keys of the same name. So if I go through this XML file, let me hop over here. So right here in anime season, right? Whoops, pop that back open. Or in genres even. You'll see that I have genres as individual elements, instead of having a list underneath genres. So I could have had a text list of horror, mystery, psychological, R, thriller under genres. That is a possibility, but instead I was able to break it down into individual elements, and then I just iterate over genres, finding all the genres inside of genres when I recompile the list. And I can do that with a list comprehension. So that's a major difference, is we don't have to save these as a list. Either way, there's not much of a difference between the two when it comes to work. It does take a little bit more effort to convert it into XML than to convert it into a JSON, since JSON can have lists in them. But at the same time, this is kind of convenient, visually speaking, to have, this is a genre. And it also gives us a little bit of flexibility. I haven't found a specific example where I've used it, but we could put something else like genres, and then, for example, quantity, if I wanted to for some reason, equals 5. Or, quantity 5, close quantity tag. That's a possibility. That specific example is poor just because there's no reason to do that. But it does let us, store other stuff in the area that would be our list, which is convenient. And like I said, it's visually kind of nice to be able to say, all right, all this stuff is genres, to confirm it that way. So there's a root element. It has character as the text, as the tag rather. Character as the tag. And then it has attributes, one attribute called name, and that is going to be the character name. And then, like I said, Python has an actual element tree class that we're going to be using. And that is going to have a element of our root to start out with. And then file name. And we'll call that tree really quick. So, being able to supply this with the file name is convenient, because then we can just call write on the tree object when we're done, as opposed to having to open up a file and write to it like we did with JSON with open json.dump. Otherwise, not too much of a difference. That's a difference between one line and 2 lines. So the way we're going to create this tree, actually we're just going to subclass off to a character like we did before. So actually what that means is we're going to go ahead and just cut this out and say root equals character.xml serialize. I like doing things on the class itself. If necessary, we can always just pull those methods out of the character. So, for example, with JSON serialize for character, we could do character JSON serialize and replace this self with character. And then in this method here, call character JSON serialize self. And then return that. And this would be no different. This would just be kicking over to this thing, and then this gets off a character everything it needs. So no difference there. I'm just doing it this way because this is the way I'm more familiar with. Honestly, the second way would be more correct, but I don't see the scope of this project extending that far, where I'm going to have multiple character classes, multiple separate character classes even, that would require that. As far as I know, this is going to work only on the character class, so there's no reason to necessarily make it its own individual function. So, define XML serialize, self, and then root is going to be character and self.name. And then I'm actually going to go ahead and copy this down. And I'm going to change this to 1:, and brackets. So this is not something we've gone through. Maybe in looking over lists, you have gotten to index notation. So I will go ahead and tell us about it right now so that everybody knows. So if I have a list, index notation, if I just put a number in here, this is the index that I'm looking for. So this goes to the very first item in the list, index 0, and returns it. If I have a colon in here and another number, this gets everything between 0 and ending at 1. So this actually returns only 0 because it stops before 1. Whereas if this was 2, it would get 0 and 1. If I leave either of these empty, then it's automatically the first and last, respectively, item. So this goes from the first item to the third item, index 2. And this goes from the first item to the last item, which in our list right here is index 2. Is actually, I take that back. It goes to the last plus 1, technically. So this would actually go all the way to index 2 and include it. This would actually be 0:3. The other thing that we should know is if I put a negative in here, that starts counting from the back of the list. So this -1 is equivalent to 2, because 2 is the back of the list. -2, we count 2 backwards, so it would be equivalent to 0:1. So that's how negative works. And then there's a way to reverse the list using those, but honestly, that you're better off just using the reverse function like that instead. There's no real reason to reverse it manually with the slice notation, index notation, slice notation. The difference in terminology is index is a single number, slice is a slice of the list. And for the record, if we look at this right, this is 0 to end, this specific slice notation right here. And that's an old way, for the record, of duplicating the list. It's because slice notation will return a copy rather than the actual list itself. So instead, nowadays, in order to copy the list, we just do list as a function. So for attribute in, and we're going to skip name because we already used name. Actually, you know what? Let's not do it this way, because we can do what I was talking about with having the aliases each as a separate alias. So we're going to do, I'm just going to use ele equals et.element aliases, and then for alias in self.aliases, L equals et.element alias, and then L.text equals alias, and then we append le.append L. So elements work like lists where you can append them and extend them, for example. We use L.text to access the text attribute of the element, and then set that equal to alias. And this alias is our list of aliases. So that gets us all our aliases into the aliases element. And then we can move on to extra keywords. So le equals et dot element extra keywords. And then for kw, and I'll do kw value in self dot extra keywords dot items, and then I just copied this down and we changed this to this element. We'll go ahead and change to kw, and then we'll change the text to value. So this is going to be a little different because, like I said before, I was setting all those to genres, for example. So this is a little different from before because I was doing, genre on lists. Whereas this is going to have each element as a separate keyword and then the text to that as the value. The other way I could do this is I could just say et element keyword and then maybe use the keyword and value as the attribute. That's another option. Otherwise, actually, one thing I forgot here. Once we had the aliases done, we want to append root with aliases. Otherwise, we're going to lose track of it. It's because I'm reusing le as the element that we're working on. So if you haven't figured it out so far, I personally have come to like XML file better as saving. So even though this looks like more work, it's really not that big of a deal. We're gonna write this once and then it's going to, function forever. We're never gonna have to really worry about it. And then for obj in char obj at, we're going to do root.append object.xml serialize. And then we just return root. So that one works exactly like up here because it's just going to return an element. It's going to basically return this part right here to us, and then it will go ahead and just append that so we don't have to type this part out again. So we come down to item, define XML serialize, self, le equals et element, item, for adder in item name, quantity, L equals et dot element, adder, and L dot text equals get adder self adder, le dot append L, and return le. Simple, straightforward. We're well familiar with this get attribute scheme that we've been using. And we just create the element, assign the text, append it, and then return the element, and the element will get appended to our character up here. Equipment. Define XML serialize. Self. Le equals super dot XML serialize. So this will return just like here. It returned a dictionary. This will return an element. There we go. For adder in equipment name material, and then we just do the same thing we've been doing. Rinse and repeat. Return the element. We got the element from the super, etc., etc. And I'm down here in backpack. Extremely straightforward. Don't have to try too hard with this one. We get the equipment XML serialized to get the element, and then that should be L. We create the contents element, and then for item in self, L.append item.xml serialize. That will return an item serialization, XML serialization. So it's going to return an element. and then we just append that element to our contents element. And so that's going to say, we're going to have a contents tag, and then underneath that contents tag, it's going to say item, stuff, item, stuff, item, stuff, etc. And then once we're done with that, we can le.append L and return le. One thing to note, because these are objects and lists, this could absolutely be up here, and then we can add to it after we've already appended it. I don't like doing it that way just because I want to make sure that I have everything done before I append it to the element. It's just kind of a get your work done first mentality before you wrap up, before you start cleaning up. That's just kind of the mentality I have. That's why I do append afterwards. Otherwise, it doesn't really matter. And we should be done. That should be everything. All our objects are getting serialized into their individual elements. We have these class elements up here, specific to character. So we're just going to hop down bottom. I'm going to go ahead and get rid of the JSON save. No, actually, we got to finish this one off. Tried to save the character before and realized, wait a second, we never finished that off. So, very simply here, tree.write. And there's arguments we could pass here, but we're just going to write it as is to the file name. So save XML character, Jimmy.xml. And we don't need this print right now. Run. And then quick fix typo. Got to get the attribute for the object ahead of time when we're doing the XML serializing character. Another change that we're going to have to make. I did mention this and I kind of forgot to take it into account. Text are strings. So we're just going to have to run through and add a string everywhere in all our XML serializes to convert any numbers or booleans into strings. Don't have to do it in XML serialize for backpack for the contents because they're going to serialize themselves. All right, and wow, bumpy today. You'll recall that up here when we're talking about the repr function, wherever that's at, oh, actually we put it underneath equipment, we had self.class.name. If we're going to be inheriting this from the XML serialize, we should really do that as well. A little sloppy today. Fortunately, all this stuff, this is the good thing. It takes zero time to run a program file, so all this stuff is getting fixed, extremely quickly. But at the same time, if we would have kept in mind what we're doing, this wouldn't have been a problem. We would have said, oh, wait a second, we're going to want equipment to come out as an equipment element. But, again, no harm, no foul, really, because it's just a quick fix. Alright, so here's our character. We have character, attribute name is Jimmy. We got a list of aliases, keywords, nuns. We've got a weapon, item name sword, quantity, worm slayer, etc. We got a shield. Backpack, let's check the contents. Contents have items, cool. And they have their quantity and name associated with them. And it looks like all our tags closed, so we are doing good. So we just got to be able to pull this back out now. So define load XML character. And the way we're going to do this is we're going to take the file name and we're actually going to pass it to the et.parse function. And that's going to give us a tree. And then we got to get the root of that tree. Again, the tree is just kind of this object that holds the XML stuff. So root equals tree.getRoot. It may seem like this is a little unnecessary, but the reason this is because elements in this module are kept kind of pure, An element isn't going to have a write function or whatever to it. So this is useful to create another class that holds all these elements and then can do stuff like writing and other utility functions. that's why, even though this root is really what we're looking at, it's useful to have this object that holds on to this root. Alright, we're going to, thinking about it a little bit, we're going to character.deserialize XML, and we're going to pass it the root. And then we're going to return that. That's going to be a dictionary that is going to pass back. And again, I don't expect deserialize XML, the stuff inside of it, to be used anywhere else. Otherwise, I would make it its own function. So I'm just going to keep it on character as a character class method. And that's just going to be a simple function for changing this XML tree into a dictionary. And then we're going to use our normal, we're going to get to reuse our normal deserialize character function on the resulting dictionary. So we're going to define deserialize XML, and we get a root off of that. And then we're going to walk through our basic stuff. We're going to start out with a dict equals dict, and we can pull the attribute name out of that. So name equals root.attribute name. Actually, we're going to do this a little differently. We're going to do dict. So this is going to be a little fancy. Root.attrib. No, we're going to do dict root.attrib. So what this is going to do is this is going to copy off the roots attribute dictionary, which right now just has name equals Jimmy. So that's how we're going to do that. We're just going to start out with the root with the dictionary starting out with any attributes that are in the root, rather than pull them out piecemeal or even via comprehension, which is what I was going to do, but then I realized this is just plain simpler. And then we're going to have to pull our aliases. So LE equals root.find aliases. So that's going to find our aliases tag. And then we're going to dict aliases equals L.text for L in LE. So we're going to iterate over that element called aliases. And then for each sub-element, L in aliases, we're going to pull the text from it. So we've got our aliases, and then dict extra keyword equals, actually, LE dot equals root dot find extra KW. So one thing I will say about this is I'm using find right now. This is only going to find the first instance of extra keywords. If for some reason our extra keywords are spread out across major elements, so in other words, elements that were within just the root, then we would have to find them all and iterate through it all and etc. to combine them into a single extra keywords value dictionary. But we're just going to find the first root element called extra keyword, and then we'll do and then we set this up as keyword as the as the tag, and then value as the text. So we're gonna do for L in LE, throw our curly brackets on L.tag, L.text. So for each of these, we assign a dictionary value using the curly brackets, using a colon. So for each of these, we're going to have the L.tag as the key and the L.text as the value. And we just close our dictionary braces. And that is done. And then I'm going to go ahead and for obj in char obj at, and I'm going to reiterate that the one downside that doing it this way with the find is going to have is that it's going to only have us finding each thing once, which may be a problem in future, and we may just have to adjust this a little bit. It's not that hard to adjust, but so far all this stuff should be singular. We should only have a single weapon, a single shield, and a single backpack. So we're going to just go ahead and do it this way. So yeah, what we're going to do is we're going to go ahead and use our object trans dictionary on each of these so that we can get the reference to the object class. And then we're going to just go ahead and deserialize XML. We'll do dict object equals, and then we'll deserialize root.find obj.capitalize. Or actually, let's just do Alright, we're going to back that up a little bit. We're going to do this here. Do class equals, and then we'll do class here and class dot name. Alright, there we go. So this will take, for example, weapon. Use the weapon string to find it in the root, and then we'll be using the weapon class to deserialize that element that the root found. And it will get added to the dictionary underneath weapon, for example. And then we just gotta return dict. And we'll be able to quickly hit here. Let me change it to XML deserialize since we were using that pattern earlier. XML deserialize. XML deserialize. And XML deserialize. Alright, so we're getting an element in here. It's going to say, for example, item. And then we're going to do dict equals dict. Item name equals la.find. Item. Actually, we can use find text item name. And that will pull the text right off for us. Quantity equals la.find text quantity. And then we just got to return that. Again, it's simple, just like the JSON deserialize. Alright, and then we're not really going to be able to inherit for equipment and the rest of the stuff. So instead, I'm just going to do it this way. So we're going to use the iteration like we did before with the attribute and find text. This more or less works the same way as get attribute like we were doing before. And then down here I just did the same thing. I just copy pasted down here. Actually, it should be dict equals dict. And then Ellie is find contents. If Ellie, so if we didn't, on the off chance that we didn't find contents, we'll just skip this part. But assuming we found contents, then this should be pretty straightforward. We've done this thing constantly. You know, item.xml deserialize item for item in L. So, I mean, just to clarify, in case we need clarification, item.xml serialize, we got the element here. We're going to iterate through the element, and each of the sub-elements we're going to pass to item.xml deserialize. And that's a list comprehension that goes into contents and underscore dict. So, I'm going to actually, let's make sure, load XML character, yeah, we finished that one off, so now we can load XML character Jimmy.xml, and that will give us a dictionary. And then Jimmy equals deserialize character dict. And then we can print Jimmy. And we should probably get around to making that representation self return name the great, for the heck of it, name equals self.name. And I'll just move this up to where we've been putting all the other methods, which is above the deserialization methods. Alright, quick memo. It's trans object, not object trans. So we gotta come up here. Trans object. Consistency, boys. And we ran the code, got Jimmy the Great. We have successfully created an XML file and deconstructed it, deserialized it, back into Jimmy. So now we have two file options. The one thing I will say before we leave, before we end the episode, is that what you should know is that the file extension doesn't mean a whole lot. So this .xml or this .json doesn't actually matter to Python or most programming languages. So you could actually, have a .character file and still encode it and decode it using the XML format or the JSON format, and it won't matter at all because inside of this file, regardless of what the extension is simply text. So if you wanted to specialize your files, you could go ahead and just change the file format on them, and your program will be able to deserialize and reserialize without any problem. So that is a useful thing to know. I don't personally see a necessity for it. I don't think there's any problem with being transparent and just saying, hey, this is an XML file, because if anybody wants to find out what's in the file, they can just open it up anyway. So you're not really hiding anything by changing the file extension. It's just kind of a clarity thing. So anyway, a couple rough spots this episode, but thank you for watching. Like, favorite, subscribe, and comment. And I will catch you next time. Next time, I promise we will start working on the rest of the program, now that we have all this stuff under our belts. So until then, have a wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you later.